Hi, and welcome back. So this week, we're going to be starting to not only continue to look at data sets, but starting to think about how to visualize our data sets. That includes things like basic graphing, but also trying to use graphs and data visualization as a way of kind of exploring our data and finding underlying patterns that we might not have known about previously. And so to start, I want to just give you kind of a basic workflow for how to think about your data set when you want to graph it. And so I'll be using this cars data set yet again as an example, just to kind of keep things nice and familiar. And so step one is typically you want to identify your independent and dependent variables. Now, if you haven't heard about those before, what that really means is that in most cases, but not always, you're going to have one variable that relies on the other or is affected by the other, but that might not always go both ways. For example, using the cars data set, miles per gallon is in some cases dependent upon the number of cylinders. If you had a 2-cylinder car or a 20-cylinder car, the miles per gallon would probably drastically vary. It doesn't go both ways though. If you change the miles per gallon of a car, you're not directly affecting the number of cylinders. The number of cylinders is an independent variable. It's something that's set regardless of the miles per gallon. But the number of cylinders can have an impact on the miles per gallon. So miles per gallon is in some cases dependent upon the number of cylinders. And so identifying that is important for how we arrange data within our graphs. And I'll talk more about that in a moment. Okay, so once you've identified which variables are independent and which variables are dependent, you next want to determine whether your variables are continuous or categorical. Continuous meaning it's typically going to be numeric. There could be decimal places. It could go from 0 to infinity. Miles per gallon is a good example of that. Categorical is something that is a series of categories. That could be brand of cereal, like Kellogg's or Quaker. But it also could be something that looks like numbers, like the number of cylinders. Cylinders are a categorical variable. They're basically a set number of things. You can be 4 or 6 or 8 or 12 or 14. There's not 4.5 cylinders. And so identifying whether your variables are continuous or categorical informs the type of graph you're going to use. If you had one categorical variable and one continuous variable, typically this is going to be represented as a bar graph or something related to a bar graph, like a box plot. If you have two continuous variables, think about comparing horsepower and miles per gallon, then we're going to be looking at more of a scatter plot type situation. And I'll be giving you examples of all of these here in a moment. And finally, if you have a categorical variable by itself and you're just looking at the number of representatives that fall within a given category, like if you opened up your cupboard and counted all your cereals that you had and clustered them or grouped them by the brand. So again, all the Kellogg's, all the Quakers together. Typically, you could represent something of that like a pie chart. So we'll be going more into these here in a moment. Okay, so our next step is to determine the values that are going to go on the x and y axis. So for those of you that need a refresher, our x-axis is going to be the horizontal axis or the bottom of your graph, and the y-axis is going to be on the side or the vertical axis of your graph. Typically, by convention, we put the independent variables on the x-axis. Independent. And then on the y-axis is where we put the dependent. And this is why it was important for you to identify what was what. And so, as an example of what this could be, let's say we're interested in low versus high sunlight and how it impacts plant growth. So we might have light being our independent variable on the x-axis and height on the y-axis. Next, we want to actually start working on graphing our data. And so with light, we're thinking about just a categorical variable to keep this simple. So we could have low or high. And since we have a categorical variable and a continuous variable, a bar graph would be an appropriate way to graph this. And so graphing our data would be the kind of means of our low light and means of our highlight. And so we would, this right here would represent the height. And so now we kind of have, you could think about this as our data being represented within this graph. Once you have your data graphed, it's really important to make sure that you've provided informative labels on your axes. So our categorical variables are pretty straightforward. We've got low light and highlight, but height, we want to be a little more informative about that. Maybe it's plant height. Oops. Plant height. It also needs some units. You know, maybe it's in inches or millimeters or meters, whatever kind of plant you're studying. And then finally, you're going to want to add both a title, could be plant height in response to low versus high light availability. And you're going to want to often have a caption. Maybe this is figure 1 of your manuscript. And then you can provide a little more detail about what's being represented here. And so just to recap, kind of the basic graphing workflow is to identify your independent and dependent variables so you know where they go on the graph. And then based on the combination of continuous versus categorical, think about what kind of graph would be best to represent them, whether it's a bar graph or a scatter plot. And then you're going to figure out which of your variables are going to go on the x and y axis, and you're going to actually graph your data. Then make sure that the axes have informative labels, including units, and then give it a title, a caption, and kind of make it a little more presentable. So I want to end with just an example of each of kind of the 3 basic graphs. Here we've got an example where we have a categorical independent variable in cylinder and a continuous dependent variable in miles per gallon. And so here you can see that we've got our independent variable cylinders on the x-axis. We've got our dependent continuous variable miles per gallon on the y-axis. And then because this is a categorical and a continuous variable pairing, we have gone ahead and made it a bar graph. And so this is just kind of like the example I used where we can see the mean of 4-cylinder mile per gallon, 6-cylinder, and 8-cylinder. But to make this a little bit more informative, and this relates back to what we covered last week in descriptive statistics, is we want to also put error bars on here, in this case representing standard deviation, to give you the viewer a sense of how much variation there is around the mean within each one of these groupings or categories. Here's an example of 2 continuous variables. And so this is from a flower data set comparing the length of sepals versus the width of sepals. Sepals are kind of green leafy things that are just below the petals in most plants or most flowers. It's not important that you actually know what those are, just that they're both continuous measures. And so here we've got what's called a scatter plot. And so you can see the sepal length and the sepal width along the x and y axes. And so every single one of these dots represents one data point. So here is a sepal that was measured for length and width, and its width was 3 millimeters, and its length was about 1 or 2 millimeters. And so you can kind of see the trend here. Something else that we've done that we haven't talked about before is coloring our data points by kind of a third piece of information. So not only do we have 2 continuous variables, we actually also have some categories. We've got the species that these were that were measured. And so we've actually colored them. So Setosa is colored as red, versicolor is green, and Virginica is blue. This can be helpful for trying to figure out whether measurements actually differ between your groups. So if we look where all the red dots fall, they're actually quite different than the blue and green dots. And so this can be one way that visualizing your data can be informative. Notice there are some things missing from this graph that are actually important. Take a second and think about what's missing. Hopefully you noticed that there were no units. Millimeters, for example, or it could be centimeters. Big difference there. So we'd want to put that. I would also say that this title is not particularly informative, but hopefully this just kind of illustrates to you what a scatter plot looks like if you haven't seen one very much. if you had been browsing the internet and looking at lots of images, and you just categorized each image you saw in a variety of ways, like whether you had already seen it an hour ago or whether it was clever and new, you would end up with just kind of a bunch of count data of counts within a variety of different categories. And so really one of the better ways to represent these types of data sets are a pie chart. And so here we can see that we saw the same meme twice. And so relative to all the others, it's actually kind of a small proportion and would be a small slice of the total pie, with the pie representing 100% of what you saw. So the thing that you saw the least of was something that was clever and new on the internet, whereas most things were overused. And so a pie chart can be kind of a nice way of visualizing those data as well. And so hopefully this just kind of introduced you to kind of the steps that I go through when I think about making a graph, and introduced you to some of just the very basic graphs. And we're going to expand on these here moving forward this week.